Hi, this is the Science Chef. In this video, I'll be answering the 2023 WAEC Chemistry essay paper that was written yesterday. If you'd like to know how you fared in that examination, then follow us through to the end. All right, let's start. Like I told you in my last video on chemistry on how to study and pass your chemistry examination, I told you that this paper 2 is 100 marks, right? And you are expected to answer 4 questions, right? And each question carries 25 marks. So let's start. So answer all questions in this section. What is a transition element? A transition element is an element with partially filled d orbitals. Elements with partially filled d orbitals are called transition elements. Okay, that's your 2 marks. Then the next question says, consider the electrons configuration of the following elements: A is 286, B is 282, 282, C 281, and D 283. A has how many electrons? A has 10, 16 electrons. B has 12 electrons. C has 11 electrons. And D has 18 electrons. Which group does A belong to? A belongs to group 6. A belongs to group 6. B belongs to group 2. C belongs to group 1. And D belongs to group 0. Group 0 or group 8. And all of them are in the same period because they have 3 shells. All right. So state the element which forms a doubly charged cation. You know what? A doubly charged cation. That's the element that will have ion of either +2 or -2. Oh, sorry. A doubly charged cation. Yeah, cation key. Not so. This is out. This is not part. That is not part. So cation is not positive. So for it to be positive, it has to be a metal, and that's a group 2 element, which is what? B, which is B, right? But if they are said doubly charged ions, then it would have been either A and B. They're still the same doubly charged cations, right? Or a doubly charged anion would have been A, right? So please, you must make use of the letters given to you in the question. Yes, even though you know that this is magnesium, don't write magnesium, write B, the letter given to you in the question. There's soluble triacylcarbonate 4. This is under acid bases and so soluble salts, right? Know that all triacylcarbonate 4 are insoluble except group 1 triacylcarbonate 4, right? And ammonium triacylcarbonate 4. So which element here is in group 1 based on the electronic configuration? It is C. So the answer is what? C. All right. So we earn our 2 marks there. Let's move on to the next one. Explain briefly why there is a general increase in the first ionization energies of the elements across the period in the periodic table. Okay, let's just go straight to the point. As you move from left to right, across the period, there is what? 1, an increase in the number of protons. 2, an increase in the effective nuclear charge. 3, relatively constant shielding effect of inner electrons. An increase in the nuclear force of attraction between the nucleus and the outer electrons. Hence, and number 5, an increase in the energy required to overcome the nuclear force of attraction. All right, so as you move from left to right across the period, there's an increase in the number of protons. Electrons are being added to the same shell. So as electrons are being added to the same shell, protons are also being added to the nucleus, right? And as protons are being added to the nucleus, there's an increase in the effective nuclear charge. That's from, let's say, period 3 now, you move from plus 11 to plus 17 or plus 18. And as that happens, the effective nuclear charge, of course, increases. And since electrons are added to the same shell as you move across the period, the number of inner shell electrons remain the same, right? Like from 281 to 287. From 281 to 287, let's say 288. Inner electrons here is 10. Inner electrons 10 are 10, 10. So they are the same, right? So, but there's an increase here. You had plus 11. You have plus 11, where you have what, plus 18. Plus 11 attracting 3 shells, and plus 18 attracting 3 shells. So which one will the force be strongest or stronger? It will be in what, between plus 18 and 3 shells, right? So an increase in the nuclear force of attraction between the nucleus and the outer electrons. And as that nuclear force of attraction increases, you will need a high amount, an increase in energy or a high amount of energy to overcome that nuclear force of attraction, or to remove the valence electron from the outermost shell. And that energy required to remove that electron is the ionization energy. All right, so let's move on to question D. So the next question here says, give 2 examples of an aliphatic compound. An aliphatic compound is a non-aromatic compound, right? A compound that does not contain the benzene ring, right? And it can either be cyclic or acyclic, right? But we will focus more on acyclic aliphatic compounds, and they include alkanes, your alkenes, your alkynes. But since we are asked to give 2 examples of aliphatic compounds, so let's go with methane, which is an alkane, and let's say propene, let's say ethanol. These are all aliphatic compounds that do not contain the benzene rings, right? Fine. So the next question says, explain briefly why alkanols are stronger than water. Okay, this is the structure of alkanol, ROH, right? And this is the structure of water. So what's happening here? This alkyl group in alkanols have what we call a positive inductive effect. The alkyl group has a positive inductive effect. So what happens? It tends to push electrons towards the oxygen atom, right? Thereby stabilizing the alkoxide ion. Okay, let's write it. Alkanols are stronger bases than water because of the positive inductive effects of the alkyl group. The alkyl group tends to push electrons towards the oxygen atom, thereby stabilizing the alkoxide ion. This is not possible in the hydroxide ion formed in water. Now, in terms of equation, we have ROH. ROH will lose hydrogen ion to become RO minus, right, plus H plus, right? The same way water loses hydrogen ion, loses hydrogen ion to become what? OH what? Minus plus H plus. Now, the R here, the alkyl group in this is the alkoxide ion. We call this alkoxide ion. This alkoxide ion, the alkyl group in the alkoxide ion pushes electrons, as illustrated here, pushes electrons towards the O minus, right? This O minus here. So the alkyl group pushes the electrons towards the oxygen atom, thereby making it what? Stable, making this electronic charge here to be what? Stable, and not leaving the oxygen atom, so that whenever a proton comes, you can always find a negative charge around the oxygen atom, right? So that makes it a better base than water, because hydrogen does not have a positive inductive effect. So hydrogen has neither a positive nor negative inductive effect. I would just say it has a zero inductive effect. So that makes the alcohols or alkanols better bases or stronger bases than water. All right, let's move on to the next question. The next question says, state the major raw materials used in the solvay process, right? I told you to read about this in topics that you should not ignore, right? I told you to read about solvay process, right? Solvay process is the industrial manufacture of sodium triacylcarbonate foam, right? And the major raw materials commonly used in this process are brine, ammonia, and limestone. The limestone here produces the carbon 4 oxide through thermal decomposition. These are the three major raw materials used in the solvay process. I know that it may not be necessary again. If you want to learn about solvay process, you can check our video on this topic. We have added the link in the description. Okay, so move to the next question. What is geometric isomerism? Right? In general, what is isomerism? Isomerism is a phenomenon whereby two or more compounds, right, have the same molecular formula but different structural formula. But when it now comes to geometric isomerism is a type of stereoisomerism, right? That has to do with how the atoms in the compound are arranged in space, right? It is common in alkenes. So we'll say that it is a phenomenon. It is a phenomenon in which two or more organic compounds with double bonds have the same molecular formula, but different arrangement of their atoms in space around their double bonds. Okay, like I said earlier, it is common in alkenes. All right, so that is geometric isomerism, and you have two types. You have the cis and the trans isomerism, right? Example of a compound, the simplest compound that exhibits geometric isomerism is but2-ene, right? That's why I have cis but2-ene and trans but2-ene. Fine. Okay. Of course, we also have a video on this, on geometric isomerism. It's part of the things I also told you to read about, right? So let's move on to the next question. Okay, in this next question, we are told to give a reason why water gas is a better fuel than producer gas. Okay, what's water gas? Water gas is a mixture of carbon 2 oxide and hydrogen gas, right? In equal amounts, 50%, 50%, right? Whereas producer gas is a mixture of carbon 4 oxide and nitrogen. Carbon 4 oxide and nitrogen in the ratio 33% to 67%. That's more of nitrogen than carbon 2 oxides. All right, so why is water gas a better fuel than producer gas? These two gases are produced from the gasification of what? Coke. When you pass air over red hot coke, you get producer gas. When you pass steam over red hot coke, you get water gas. So why is water gas a better fuel than producer gas? Water gas is a better gas than producer gas because the two components of water gas are combustible and are in equal proportions. Whereas while producer gas contains a non-combustible nitrogen. A non-combustible what? Nitrogen, which has the higher what? Which has the higher proportion, right? In other words, carbon 2 oxide and hydrogen can bond, will bond to generate more energy, right? Whereas nitrogen will not bond. Carbon 2 oxide will bond in oxygen to produce carbon 4 oxide and generate heat energy. Hydrogen will bond in oxygen to produce water or steam and produce more energy. But in producer gas, nitrogen does not easily bond in oxygen, right? So it means that it's only carbon 4 oxide that is available for what? To be used as a what? Fuel in producer gas. And besides, it is even in a very small what? Proportion. It's only about 30%, while the other one is almost what? 70%. So which means that the heat energy that will be produced by water gas will be higher than that produced by producer gas, right? So you can add that, hence water gas produces more heat energy than producer gas when it bonds, or when they bond, whichever one. All right. The next question says, define the term heat of combustion. Define the term heat of combustion. What is heat of combustion? Now, heat of combustion is the amount of heat given off, or you like say liberated, or released, because it's always exothermic, right? When we are told to define heat of combustion, not standard heat of combustion, but I will always use the standard definition for it, right? The definition for standard heat of combustion to define it, but I always put those other terms in what bracket, right? When 1 mole of a substance, so I'll put this in bracket, when 1 mole of a substance bonds completely, very key, when 1 mole of a substance bonds completely in oxygen. So is the amount of heat released when 1 mole of a substance, or when a substance bonds completely in what? Oxygen. But if they had asked us to define the standard heat of combustion, I mean the amount of heat given off, liberated or released, anyone, right? When 1 mole of a substance bonds completely in oxygen under standard what? Conditions. So then move to the next question. The next question, we are asked to state Faraday's law of electrolysis, right? So what does it state? It states that when 2 or more electrolytic cells are connected in what? Are connected in series during electrolysis, the number of moles of the elements deposited or liberated is inversely proportional to the charge on their what? On their ions, right? When 2 or more electrolytic cells are connected in series during electrolysis, the number of moles of the element deposited or liberated at the electrodes, remember the electrodes, is inversely what? Proportional to the charge or charges on their what? Ions. Let's say charges on their ions. Okay, so that is the Faraday's second law of electrolysis, right? Then the next question says calculate the amount of silver deposited when 10(9)20 coulombs of electricity is passed through a solution of silver salt. All right, so the first thing we do here is to write the equation for the reduction of what? Silver, and that will be Ag plus electron giving us what? Ag solid, right? Ag aqueous, fine. So yes, what do we have here? Okay, so here, what do you mean? We have 1 Faraday producing what? 108 grams of silver, right? So calculate the amount of silver deposited when 1920 coulombs. Okay, fine. That's the only thing we are given here. So we are given Q. Our Q here is what? 10(9)20 coulombs, right? Fine. So from here, you can see that 1 Faraday will deposit what? 108 grams of silver, right? Which means that what's the value of 1 Faraday? It's given to us here 96,500. So it implies that 96,500 coulombs will deposit what? 108 grams of silver. So what amount of silver will 1920 coulombs of electricity deposit, right? If we solve for our x here, this would be 108 grams times 10(9)20 coulombs all over 96,500 coulombs. So let's cancel out this. Now we have 108 times 10(9)20. What's that divided by 96,500? So this gives us 12.221 grams of silver. All right.